Hello again. Previously, we have started the design of the tall building G plus 23 stories, and we have conducted the design for considering wind load. Now we are going to do the design considering the seismic forces. So I have already opened the tab. Now I am going to open the tall building design file. Okay, so first we have to define the seismic load. Go to define load patterns. Now type seismic. From type drop down menu, select seismic, and the auto lateral load you have to select the IS code, which is IS 1893 2002. Click add new load. Now we are going to modify lateral load as we did in earlier video. Here we have to deselect the X and Y direction eccentricity options, because we are going to perform only X and Y direction, not there is no eccentricity in this assignment. So as per code, the seismic zone factor Z, we have to find it, open the code. As we are designing it in Bangalore region, Bangalore falls into zone 2, which is this blue region. Now in table 2 you can see the zone factors. Yes, table 2 zone factor. For seismic zone 2 it will be 0.1. So it will be 0.1. Now the site type, from code you can see we are assuming this is a medium soil. The building is situated in a medium type of soil, so it will be type 2. The importance factor, again I am going to the code. The importance factor will be taking it as 1, as it is a residential building. Importance factor 1. Now response reduction factor, again I am referring to code. It will be in table 7, I think. Yes, table 7. Response reduction factor will be 3, as it is a ordinary RC frame, moment resisting frame, so it will be taken as 3. Okay, now click OK. Now the seismic forces are designed. Now go to analyze, set load cases to run. Now here we don't have to design for wind load, so select wind load and select run do not run case. Now you can see in the action panel the do not run is written, so we'll be now clicking run now. It will take some time. Okay, the analysis is complete. Now if you click on any of the member, right click on any of the member, you can see the drift of that element, displacement on drift of this element. You can also click the start animation to animate this structure. We are going to just design it. Now go to concrete frame design, view revise preferences, and IS code is selected. Just select start design / check. Okay, this error might occur, just ignore it. Okay, now see, it is saying that 8 concrete frames are failing. So do you want to reiterate analysis and design? Yes, select yes. It will be redesigning, and first you will reanalyze and then it will redesign with greater number of greater dimension of the section. The analysis is complete. Now it will be checking for design. This error occurs because the wind load case is defined, but the in analysis we have selected the do not run wind cases, so the error is happening because of that. Now I have seen several times this type of error is occurring, like 8 concrete frames are failing or 7 concrete frames are failing, but actually no frames are failing. So in the next time I'll just click no and check whether any frames are failing or not by clicking the view verify all members passed. Okay, I'm clicking no. Okay, you just see, if I click on verify all members passed, it is saying that all concrete members passed the design check. So why it is showing that all members not passed? Okay, so the design seismic design is complete. Now we'll be doing the response spectrum analysis. So for that, first we have to unlock this model. Unlocking the model. Okay, so first we have to define the function, response spectrum function. Click define functions and response spectrum. Now choose function type to add. Here you have to select the IS code. You can see IS 1893. Click add new function. Now in the function name write response spectrum. Okay, the seismic zone factor is 0.1 as we have discussed earlier. You can see the code again, zone factor 0.1, and soil type is 2, and the damping ratio is 5% for concrete members, and for steel members it is 10%. So Okay, so it will be 0.05. Just click OK. So the response spectrum function is created. Now click OK. Now go to define again, click load cases, and here you can delete the wind load. Okay, delete case, and you can also delete the, no, we don't have to. Okay, add new case, click add new case, give it a name, response spectrum. Now in load case type you'll select response spectrum, click add. Okay, now before adding you have to see the units of the acceleration, whether the acceleration units are in millimeter per second square. Okay, the acceleration units are millimeter per second square, you can see. Now go to define load cases, add new case, okay, I'll be deleting the wind load case, add new case, response spectrum, select response spectrum, click add, acceleration u1, this is in x direction, function name is response spectrum, and the scale factor is in this case the scale factor will be 1633.5, which is derived from the equation. Anyway, it will be 1633.5, which is G by I into I have forgotten the formula. Anyway, the scale factor is 1633.5 in this problem. We are going to add a new load which is in y direction. Function, the function name is response spectrum, scale factor will be again 1633.5. now directional combination will be CQ C3. It's not necessary to change it. Okay, now click OK. Okay, now go to analyze, set load cases to run. As we are doing the response spectrum analysis, we will be disabling the dead and live load. So select dead and live load and click do not run. Now click run now, and mind that a error will be shown. Don't worry about that. Okay, I think I have selected the wrong view. Well, it doesn't matter. Okay, in the 3D view you can see the displacement and the drifting of the members. It will take some time, I think. Okay, now we can design it. Click view revise preferences. IS456 is selected. Select concrete frame design. The error will occur, don't worry about it. Okay, that is pretty fast. Okay, now select the verify all members passed. You can see all concrete members passed the design check. Now we'll unlock the model. Now we are going to do a time history analysis in this model. So go to define functions, time history. From here you have to select from file, because we will be uploading a file, adding a file from Bhuj earthquake. So go to click add new function, select the function name. Before selecting the function name, click browse. Here you can see the, yes, this is the time history data. Now edit the file name, time history. Okay, now you have to select fixed format, and header lines to skip, it will be 9, and the number of points per line it will be 1. Okay, this just change the graph. Click OK. Click OK. Okay, now define, go to define load cases, add new load case. Okay, we have to delete the response spectrum. Delete response spectrum, click add new case. This will be time history analysis, so the name will be time history. Select load case type as time history and click add. Load pattern is acceleration U1 and function name is time history, and scale factor value will be what? 1633.5. You don't need to change any of that. Click OK. Click OK again. Now go to analysis, select set load cases to run. You can see all the dead and live loads are not running in this case, do not run. Only seismic and time history analysis are running. So click run now. Okay, it is analyzing, it will take some time. Then we have to select the design. Okay, time history analysis is done. There are some warning message or informations. Anyway, again you have to start design and check. Yes, if you get this kind of errors, don't worry. Okay, analysis and design sections differs for 12 concrete frames. Select yes. It will again reiterate the analysis and design. It will reanalyze the design, and again it will redesign the model. Analysis is done. Now you'll be getting the error message. Yeah, this is. Okay, you see, no errors are there. Yeah, you can see the different sections and properties by clicking right click on that member. Now we can select verify all members passed. Yes, all concrete members frames pass the design check. So this is the seismic design, response spectrum analysis and time history analysis. You can see the reports here, project report. By double clicking the project report, you can see the project report. It will take some time. Quite some time actually. If the detailing option was here, you can see the detailed RC designs of the columns and beam sections. Okay, the report is generated. You can see it here by scrolling, or yeah, you can see the story definitions, grid dimensions. Here the index of the report is given. Suppose you want to see the material properties, you can just double click these, or frame section properties, area section, all are given. So this is it. Just save your project. So thanks for watching.